Looking at this question, it says a statistician collected this data, and then it says performed a linear regression. Linear regression is pretty important here, and we also looked at plotting the residuals. So before we get started answering the question, let's get this table into DESMOS. So to create a table, we click on this plus button in the top left corner, choose table, and I'm going to enter in all the data from the table, carefully checking to be sure. I just click over here, making sure that I put in all the data correctly. So as you see, what happened here when we did that is it plotted these points for us over here on the graph. And so I can zoom in and out. I can use this to zoom in and out, or I can move it around. So I'm going to zoom out for a second. So then, since this says that it was linear regression, that means I need a linear regression equation. So to do that, we're going to punch in y1, and when I click 1 after the y, it automatically puts it in this format. After that, we're going to use the tilde button. This button is shift and the number to the left of 1. If you haven't ever used that before, if you find 1 and then the button to the left, that's given us this button. Tilde is what that's called. Then mx1 again plus b. So notice here we have our line of best fit going through the points. It tells us that our m is approximately 2.6, our b is approximately 5.38. We have some information here, but here's where we're looking for residuals. And it says in the problem, plotted the residuals. So your information about residuals, it's basically telling us how close are the points to the line. And basically, this question is asking, based on the residual plot, the statistician decided to exclude one data point. They performed a linear best fit on the set of remaining dots, and the result was a new linear better fit linear model. So they want to know which one did they exclude. If we're going to exclude something, it's probably going to be this point or this point, and we want to choose the one that's the farthest away from the line. So it's easy to see here if we click the plot. So what this does, it gives it to us in a graph, but it also plots it on the x-axis. And if you notice, these points are correlating with these blue points. So the purple points are telling us how far above or below the line of best fit these points are. And of course, we notice that this point, if I click on it, is the point 8.2. And it tells us this is not the y value of that point. 8.2 is the x value. The y value is telling us that this point is 2.66 below the line of best fit. We were also questioning this point. This point, the 8.5 point, was 1.7 above the line. So we're looking which one is a higher value, which one is farther away from the line. It doesn't matter if it's negative or positive because the negative says it's below, positive means it's above. Therefore, I would choose the 8.2 point. You can also look at this in the graph. If we look at the graph, we're trying to determine which of these numbers, again, the negative just tells us that it's below the line, so don't worry about that part. Which one of these numbers is the highest number? And obviously it's this one with the negative 2.657, go on and on and on. So if I go over here, that tells me that this is the point that should be excluded. This is the point that's the farthest away from the actual line of best fit. The question asks, which one did they exclude? It's the 8.2 point, and here we go, D, 8.2 and 24.3. That was the one that it was the farthest away here with the blue dot away from the line. We can also look at the residuals and tell that it's farthest away here. It's 2.66 below the line, or we can look at the table here once we hit plot residuals to find the value here. Again, the answer would be D.